Hi all, my name is Gulshan Banu, working as an assistant professor, AI and DS department, SNS College of Engineering. In the previous video, we saw the topic which is related to Unit 5, that is ImageNet. I explained you certain basic concepts of what is ImageNet and what is ImageNet structures, and that is related to WordNet hierarchy. And the next thing we saw is data annotation and quality control. We saw how images are being classified and how it has been hierarchically analyzed and taken. Next we saw how we have to annotate those data and quality control is being done. So in this video we will see like what is ImageNet large scale visual recognition challenge is all about. This can also be named as ILSVRC. So ILSVRC is nothing but it is a kind of an annual challenge which was implemented from 2010 to 2017. Why is this being done? Is just to benchmark certain images or benchmark certain patterns of data that is being implemented in every images. So every image will have certain approach. So a same person will be analyzed differently in each and every day, right? Likewise, every images will be analyzed in different patterns and different methodologies. So for that, this benchmarking was done. So this was used as a subset of all these ImageNets with thousands of categories. Okay, so why was this being done is to improve the quality of the computer vision and also improve the quality of the classifications of how the images is being classified. So this was done with the three process. The first thing is annual competition. The second thing is standard evaluation benchmarking. Next thing is accelerated deep learning research. First is there will be a competitions for each and every year. Just for the image classification analysis, competition is nothing but the analysis of the images and the better quality process of how it is being done. Next is the standard evaluation benchmark. Okay. Next thing is accelerated deep learning research, like how we are going to evaluate it, how we are going to advance the research, how we are going to process the image in even more efficient way. So now, what was the task? What was the basic task that is being given, and what was the thing that was being given is, first the key task include classification and object identification. So why is this deep learning, machine learning, artificial intelligence, all this way being what is? Just to simplify. Okay, simplify based on the machines or based on the algorithm that you are going. So in this image classification, the two major thing that will be held is the classification and the object localization. Okay, what is this classification? As I said you in the previous video, it will classify when you are giving it as a dog, it will classify either it is a mammal, it will classify either it is a carnivorous, then it will classify which dog, next it will classify which type of dog that you are being executed. So these are the things. Localization is the process that you are executing, like this should be in this platform, this process or a plant should be in a plant category platform, all these things. Okay, so for all these process there should be algorithms assigned to it. The three process that you are going to do is assign the image label, predict it, and you have to find the error. First you will be assigning, then you have to predict, next you have to give the metric of ranking or the error. Okay, the next thing of this ImageNet classification and the continuation is the AlexNet, which was done in 2012. So what is this AlexNet? It is just a revolution in the field of deep learning process that has a minimum error rate. Okay, so in this it had almost 8-layer CNN architecture, GPU trained enabled breakthroughs and major performance improvements. The first thing was 8-layered CNN architecture. 8-layered CNN architecture, which is CNN architecture was explained in the previous video. So 8-layer is nothing but the layer of the CNN process. So why are we using CNN? CNN is the root cause for the ImageNet classification and AlexNet process. So GPU trained enabled breakthrough is the global positioning unit. Okay, now it has this AlexNet was having certain global positioning process. Next, the performance was really high. Now what were the advantages is New architectures like VGGNet, GoogleNet and ResNet all were being implemented in this process. Okay, all these made the process to do in an efficient manner. The next thing is the impact on deep learning. How this has impacted the AlexNet and the classification, everything impacted on deep learning is, it is first a pre-trained model. Next, wide applications were used and it enabled the real world AI solution. These are the impacts of deep learning. Next is the limitations and the future directions is, ImageNet has bias in geography and demographics and focuses mostly on objects. Okay, see, for every invention there will be a plus, there will be a minus. Likewise, in this also there is certain limitations of everything. You have to give the data to that, and you have to detect the object. You have to tell the image that this is being done, this geography is given, this process you have to focus, etc. Right? So there are certain limitations which is being given, like address the data size bias, expand beyond object recognition, explore self supervised learning. So everything we have to address to the machine, right? So the first thing is that expand beyond object recognition. As I told you before, the objects only which we are being trained or we are being given is being implemented, and it will detect the object. So that should be avoided. Next thing is explore self-supervised learning. So this is all about deep learning and the process of how it has been executed. So these are the process of how ImageNet is being evolved, the AlexNet is being given, and the process of this is being executed. So as of now, thank you. So I hope that you understood the topic of ImageNet. Thank you. Have a good day.